This is Algebra 2 with trig, 1D.1b. We're solving systems of equations algebraically. Now in the past, you have used substitution and you've used elimination to solve a system of linear equations. But when we come down and look at our problems for today, we're talking about a circle, a parabola, intersecting with a line. So elimination is not going to work here because you have unlike terms. So we're going to talk about substitution. There's some basic rules with substitution. First thing we want to be able to do, or be sure to do, is to isolate a variable. You want to get a variable by itself. So in this case, I see my x is already practically by itself. I'm just going to move the 4y to the other side. And that isolated the variable. It'd be a little bit more complicated down here. You'd have subtracting and dividing to do. So that's why that was the best variable to solve for. But your choice, it doesn't matter. Number 2, we're going to substitute. This expression it's called an expression because we're just substituting in the minus 4y plus 1. There's no equal sign with it. It's not an equation, it's an expression. Substitute the expression into the other equation. So we're going to plug this value, this expression, in for the x, because that's what x stands for. In terms of y, x is negative 4y plus 1. So 3 times x, which is negative 4y plus 1. Then we add 2 more y's, and that should give us the value of negative 12. We started out with 2 equations because we had 2 variables. You've got to have 2 equations if you're given 2 variables. Now we've narrowed it down to 1 equation with only 1 variable. So we're going to solve for the only variable, because it's the only variable that's there. So we distribute through. Group your y's together. Subtract your 3. And divide by your negative 10. And that comes out to be a positive 3/2. That's your y value. So we solved for the only variable we had. We're going to plug this answer back into an original equation. Either original equation. I would even consider plugging it into this one since it's just a manipulation of the original. Where you don't want to plug that is into this equation. You can't solve for x. There's no x. You wouldn't be solving for anything. You need to solve here where x is already by itself. So x equals negative 4 times 3 halves plus 1. You would multiply the top number, so negative 12 divided by 2 plus 1. Negative 6 plus 1 is negative 5. So our answer is x is negative 5. Y would be 3 over 2. That's using substitution to solve the system. We're going to use that method, these same 4 steps, to answer these questions. In this one, we have the y by itself already. So what are we going to do with this value? We're going to plug it in for y. Everything else stays the same. Show your work. Six minus 3 is 3. We still haven't squared it yet. Now, some people make a mistake here. They think they can take the square root because everything's square rootable. You cannot take the square root of this. Because of the plus, you can't take the square root of that. We've discussed that before. You've got to move your like terms together. Now we can take the square root of both sides. And don't forget, when you take the square root of both sides, you've got to get plus or minus. So we know what our x is, and we actually know what our y is. So we're done. It's 4 comma 6, and it's negative 4 comma 6. This was a circle that had a center at positive 3, a radius of 5. So it goes all the way up to 8. From 3 and a radius of 5 takes me up to 8. So my 6 is going to come across here. And that shows us we should have 2 answers. And it'll be symmetrical because our center is on the y-axis. That's why we got 2 answers. And they were symmetrical. Positive 4 and negative 4. So you go ahead and try this one. Pause the video and work through this. Here we see that y is already isolated. That's the first thing we do, isolate a variable. They've done it for us. So we know what y is. Y is 2x. So I'm going to plug that expression back into the other equation. So that becomes 2x is going to be squared. Now, is that the same thing? Can I just put a square up there? I have to use parentheses because I want to square the entire 2x, not just the x. So this becomes 4x squared. 2x times 2x is 4x squared. That would be a common mistake. Now, some of you might notice you got a common factor in here. You could divide the 4 out. That'd be okay. You could do that. But what I want to be sure that you do is realize you need to bring, if you have 2 different types of x's, you need to bring all the values over to the same side of the equal sign. You can't take the square root here. You don't know the square root of x. You can't just square root it. So now this is in factored, or it says in expanded form, but we're ready to be factored. We're like standard form. So I pull out my GCF, what I have in common, and I do the zero product property. And I got 2 answers. I got an answer of 0 and an answer of 2. So the directions say, plug the answer back into the original equation. We know what x is. I think this would be the good one to use. So we know x is 0. 0 times 2 gives us 0. We also know that x is 2. So 2 times 2 is 4. So when x is 0, we got 0. And when x was 2, we got the answer of 4. So rewind that and see if you can do the problem on your own now. Let's try the next one. Pause the video. Practice these problems. What would you do? Try to figure out either your misconception or your confidence that you know what you're doing. You can't sit there and copy me. Okay, let's try this. Again, we have a variable isolated. That's nice. So we know what y is. Y in terms of x. So x squared plus what this y is, and the y is being squared, and it equals 10. Now, how do we handle a binomial squared? We've mentioned it many times.
Take that binomial and talk about itself.
You've got to write it twice. You can't distribute in. We're going to say 3 times 3 gives us 9x squared. 3 times 10 would be negative 30. Another negative 30 is negative 60x. And 10 times 10 is 100. So if you notice, if you would have distributed, you would have gotten positive 9x squared and positive 100, but you never would have had your b term in between. So collect your like terms. Subtract your 10 across. So you have your quadratic that equals 0. This is the quadratic that combined these two equations together. So what could we do from here? We can get that 10 out of the way. That makes factoring it that much nicer. So we get the answer of 3. This would also give us 3, so we don't need to write it twice. It's 3. And the 10 doesn't equal 100, doesn't equal 0. So that's irrelevant. You just divide the 10 away and it disappears. So you're only working with your two factors of your quadratic. So now we're ready to plug this 3 back in to this original equation. So we're getting the answer of 3, 1. Okay, we'll come over here to our last one. Of course, this is going to have some trickery to it. It's the last one. I'm looking for a variable to isolate. This has a y squared with it. I could, but it doesn't look nice. I get a fraction. Let's get this one by itself. So I've isolated my variable. So we have 8x plus 3x plus 6, that's being squared, and 24. That's 3x plus 6, and 3x plus 6, 24. Three times 3 makes 9x squared. 18 and 18 makes 36x. And 6 and 6 makes 36. Plus the 24 extra gives us 0. The x squareds, it's only the 9x squared. The x's are both positive, so that's 44x. And our constants would be 60. So things we've talked about before, this looks like a pretty evil one to factor. There's no GCF to pull out. You can't take the square root of the last term, so it's not a perfect square trinomial. We have learned about different tricks with our calculator. 9 times 60. 9 times 6 is 54, and an extra 0. 9 times 60 is 540. Divide that by x, and then add your two columns together, and you're looking for the number 44, if you're going to try to factor that. When you go to a table, you can't get 44. So we're not finding this to be factorable so far. There's another way to test to see if it's factorable. Is to use the discriminant b squared minus 4ac If that is positive, there's two solutions. Negative, there's no real solutions. And 0, there's one real solution. So let's use our discriminant. The b value squared minus 4 times a times c. That gives us negative 2, 2, 4. If that was a perfect square, if that was the number 400, or 144, or 121, or 81, whatever, if it's a perfect square, then we know it's factorable. This is not a perfect square. It's not factorable. This is negative. So this is actually going to be no real solution. We couldn't figure out how to factor it. We tried a couple different ways. We tried with the calculator. We tried looking at the discriminant to see if it was a perfect square. It was not factorable. We could not go any further with the quadratic formula because it would be an imaginary answer because your discriminant is negative. This has no real solutions.